We can also conduct what is called a matched pairs dependent samples hypothesis test. So here we start off with one dependent variable that is measured on the interval or ratio level. So we go out into a population, we take a random sample, and we measure something. Maybe it's how afraid are you of crime during the day? You could then go up to that same person and ask them, how afraid of crime are you after dark? So what we can do is we can effectively measure the individuals in our sample twice. And what we can then do is take those two measurements, take the difference between them, and create a new dependent variable. So we might be interested in things like how much more afraid are people at night versus during the day. As an example, we consider initiative laser point. So initiative laser point involved 48 different hotspot locations. So high crime areas, areas that received high numbers of calls for service. And in this study, I was interested in the number of calls for service at 2 different time points for these 48 different locations. So here in the first column, I have 48 locations. Here in the second column, I have all of the calls for service that were made in 2011. I then went back in 2012 and figured out the number of calls for service for these exact same locations. I then took those 2 different levels and I took the difference between them. So I end up with this 4th column of differences in calls for service between 2011 and 2012. So I'm interested in these differences. If there's a big difference, then that's going to tell me that something was different between the 2 years. So again, I can conduct a formal test of hypotheses. The null hypothesis is that there's no difference in calls for service between 2011 and 2012. Now, what's really important about this test is that when we conduct it, what effectively we're doing is we're conducting a one population test of hypotheses. In this case, though, what we're doing is we're testing it on that variable that recorded the differences between those 2 measurements. Previously, we had talked about someone making a claim about the true population average. So here we do the same thing. We claim that the true population average for those differences is 0. So what we're effectively saying when we say this is that there's no difference between the number of calls for service at 2011 and 2012. The alternative hypothesis might be that something is happening. As part of Initiative Laser Point, the belief was that this new policing strategy would have an effect on these different locations, that it would lower the number of calls for service. So this gives us the alternative hypothesis that the number of calls for service in 2011 were greater than those observed in 2012. Now, this is just one alternative hypothesis I could have chosen from. So here are the 3 different alternatives I could have picked. Again, I could have said that there was a difference between the 2, but that I didn't know what it was. So on this slide, it should read that mu sub d is not equal to 0, that there's some difference. The other 2 options could be that the difference is greater, so there are more calls for service in 2011 than 2012, which would suggest that the policing strategy had a strong effect. Or it could be that the population average of the differences is less than 0. So this would tell us that the number of calls for service were actually lower in 2011 than in 2012. When conducting this matched pairs test of hypotheses. These are our 3 alternative hypotheses. Step 2, we set our significance level. So I set alpha to equal to be 0.05. Step 3, we determine the appropriate statistical test. So here, we're conducting a difference between 2 population means test, assuming dependent samples. We know this because 1, we're looking to see the difference between 2 populations, and 2, because the samples are dependent on one another. If you think about somebody and you think about how they respond, say, to their fear of crime during the day, if you then ask them again what their fear of crime is like at night, their nighttime response could be dependent on their daytime response. In this case, we measured calls for service at these 48 locations. So whatever stuff was going on within those locations to affect calls for service, that was still happening. So when we went back and measured them again, a lot of those same factors were still in play, still affecting the number of calls for service. Step 4, we then calculate our p-value. Again, this is all handled by SPSS. Here we see a p-value of 0.027. We then compare the p-value to our alpha level. And we see that the p-value is once again less than the alpha level. This suggests that under that doubting scientist perspective, under the belief that the null hypothesis is true, under the claim that there's no difference between calls for service between these 2 years, under the argument that initiative laser point had no effect, we went out into the world, we collected data, and we saw a difference. So under that belief that nothing is happening, what we saw, according to this p-value, is a pretty rare event. So since the p-value is less than our significance level, we can reject the null hypothesis and accept the alternative. In other words, at the alpha equals 0.05 level, we have sufficient evidence to conclude that the number of calls for service was greater in 2011 than it was in 2012. So this shows us that initiative laser point was able to reduce the number of calls for service among these hotspot locations.